All right, hi everybody. This is the review for the Unit 2 test for Honors Pre-Calc. There are 16 questions total on the test, 5 on the non-calculator, and 11 on the calculator. Now, the non-calculator part, this is numbered like 1, 2, 3, 4, 5. That would be probably just numbered 1 on the test. So these first, what I'm calling on here, the first 8 questions, it really represents 5 on the test itself. So in order to graph this thing without the calculator, which is obviously the goal, the first thing you have to do is completely factor it. It is factored by grouping, and the first two have x squared in common, leaving you with x plus 5. The next two have a negative 2 in common, leaving you again, of course, with that x plus 5. So bring the x plus 5 out, and we have x squared minus 2. So we will have x-intercepts at x equals negative 5. And here we would get x squared equals 2. We get x equals plus or minus the square root of 2. Now, I know this is a little bit awful in that you don't have a calculator. So this is maybe a bad example in the review. It's not going to be like that. You could, of course, if you were to have a radical, you could approximate. So we know that it's bigger than 1 and smaller than 2. So anywhere between positive 1 and 2. Right? Because you know it's bigger than 1 because the square root of 1, that's 1. And the square root of 4, that's 2. So it's somewhere between 1 and 2. And so obviously since we're just drawing a sketch, close will be good enough. The y-intercept is your constant. And the x-intercepts we just calculated at negative 5 and positive and negative, 1.7. This is odd and positive. So your end behavior looks like x to the third. So as x goes to infinity, y would go up. And as x goes to negative infinity, y would go down. Of course, we have no double roots. All 3 of our roots occur once. So we will not have any bouncing. We will not have any sliding. So a quick sketch of the graph. If we count by, probably count by ones. There's our y-intercept. And we have negative 5. And then positive and negative somewhere between 1 and 2. So again, this end would go up. And each intercept has no special property around it because none of them are multiples. Now for number 6, you can see that it is not factorable. And you're given 1, 0. And so we're going to put the 1 out here, do synthetic division. Make sure you have all of the coefficients in order, which we do have. Bring this down. Now we should end up with 0 here. So if you don't, then it is your mistake. And so we are left with 2x squared plus 5x minus 3 equals 0. I'm going to try to factor this. You could use quadratic formula on it if you wanted to, but since the numbers are small, I think factoring it. If we put the 2 out, oops, it's not a 2, it's a 3 and a 1. Sorry, if we put the 3 out here, this is 6. So I can easily get to 5x by making that a 1. So the other 2 answers are x equals 1/2 and x equals negative 3. On the non-calculator part, you're going to have to show that you can figure it out using other methods besides factoring and besides putting it into the calculator. Now this graph is designed to be easy. You can tell, first of all, just to pay attention to some patterns. This is reflect over the x, so that means we draw it in the other 2 quadrants. Of course, your vertical asymptote, and you can easily find that you get x equals negative 1, or you can tell by looking at that it goes left 1. That's up to you. And of course, this minus 3 is down 3. So our asymptotes need to go in the graph, down 3 and left 1. And again, it's a guess. We're going to draw it in the other two spots, the upper left and the lower right, due to the fact that that negative sign was in the numerator. All right, so this is a little bit extreme. You wouldn't have this many, but just to practice it. So we have a slide here at x minus 1. This one would be x minus 1 to the third. This one would be x plus 1 squared, just because of the bounce. And this one would have x minus 1 cubed, and this would have x plus 1 with no multiplicity in it. You're not really going to be able to tell too much from the y-intercept. That's intentional. The idea is you can tell by the end behavior and by the factors. Oh, sorry, I forgot. I was like looking at where's the 3? So this one would also have the x minus 3 in it. And of course, so that makes this one b. And the fact that the ends are positive, right? We know this is positive. That makes this one a. So now we have, here's where the x plus 2 is. That kind of sticks it out a little bit. That makes this a little bit more obvious that this is c. And this one, of course, because the end behaviors go the other direction, this one would be d. The answers might be wrong on the back, apparently. And then we get to the calculator portion. Volume. Volume requires all 3 dimensions. And as you can see, we subtracted x from both sides, both ends. The height of the box, if you were to fold it, would be just that little x tab. And then we would have 25 minus 2x, and we would also have 20 minus 2x. You would type this right into the calculator in y sub 1. Adjust your graph so that you could see it. You will have to adjust your graph. Maybe make them all, I don't know, 20s. Maybe you don't have to adjust it. And you would look for the maximum. So it would be second, calculate, maximum. Your x value is your height, and you get 3.68 inches to the nearest 2 decimal places. And then when you plug the 3.68 back into here, you just have to do the arithmetic yourself. So 25 minus 2 times 3.68, we get 17.64. These are in inches. And then 20 minus 2 times 3.68 gives us 12.64 inches. Finding the zeros. You will have your calculator here. It does say find all of the zeros. You can expect probably there's going to be some imaginaries, but certainly put it in the calculator. Look at the picture, look at the graph, see if you can figure out some. I'm going to guess you're not going to get them all. So I'm just going to start by factoring. First two have an x squared in common, and you're left with 2x minus 1. Next two have a positive 4 in common, and again, you're left with 2x minus 1. So x squared plus 4 and 2x minus 1. X squared equals negative 4. Here we get plus or minus 2i, and here we get x equals 1/2. You can tell you got them all. Remember, your degree tells you how many solutions you should have. For number 11, 14, 7 times 2, and I'll get us to 5. But this is x squared and x squared. To make the 5 negative, be positive 2 and negative 7. So here we get x squared equals negative 2. When you take the square root of something negative, bring out the I, please. 2 we don't know the square root of. Here we get x squared equals 7. So x equals plus or minus radical 7. Even though you have a calculator, I mean, you can leave the answer in simplified radical form. That's fastest for you. You could put them as decimals if you like, but that's just another step. Horizontal and vertical asymptotes. Horizontal asymptote is the one where you know the pattern, and it looks like our degrees match. So we would have We should probably factor it, although if you factor it, you're going to put the degrees matching anyway. Horizontal asymptote is y equals 1. Before you do the vertical asymptote, you better factor this just to make sure. Looks like we would have 5 and 1 positive. On the bottom, x minus 5x plus 5. So we do get rid of this factor because this whole cannot be a vertical asymptote. The y horizontal asymptote remains the same because it's 1 over 1. But the vertical asymptote is only a single asymptote because then the other one is a whole. Remember, it cannot be both a whole and a vertical asymptote. So remove the whole first. Always find the whole first. If you don't have one, great. Same thing is true in this one. If you have a whole, you have to find it first because it impacts what numbers go on the number line. So I'm going to factor this before I do anything. These have a 2x in common. Leaves you with x squared minus 2. The denominator, x squared minus 4. It's going to factor again. The denominator has an x squared in common. Leaves you with 3x plus 4. I'm going to do this one more time just to have it all written out. 2x, x minus 2, x plus 2, and x squared times 3x plus 4. So they do have a common factor in the fact that you have an x top and bottom. So the x is gone here, and only one x is gone from the denominator. So we do have at least one less thing to put on the graph. So the numerator gets set equal to 0. So we get x minus 2 equals 0, x plus 2 equals 0. So now we have 2 and negative 2 on the graph. The denominator also gets worked, but you have to set the denominator not equal to 0. So in the denominator, make this one blue, x cannot equal 0 and x cannot equal, let me start from the beginning here. 3x plus 4 cannot equal 0. So this is x cannot equal negative 4/3. All of these numbers go on the number line in order, small to large. So we have negative 2. We're not sure about that sign yet. Then we have negative 4/3. Not allowed to equal, so this is open. 0, open, not allowed to equal. And then positive 2. And so revert back to the symbol in the original problem. And it looks like it's got a line under it. So anything that we don't know right now, these would be colored in. Then you select a number. You cannot select a number on the number line. So I'm going to select x equals 1, which of course is right here. Plug that back into the original. So we would end up with 2 minus 4 over 3 plus 4. Is that greater than or equal to 0? This is negative 2/7. So no, that doesn't work. And so then these are our intervals that do work. And we'll translate these into answers by looking at the graph. So negative infinity to negative 2. Negative 4/3 will get parentheses. 0 gets parentheses. 2 gets a bracket, infinity, parentheses. So there's 3 sections there where the graph works. Equation of a slant asymptote. This is long division. This is how it'll be on the test too. It doesn't really go with a graph or anything. It's just you doing long division. So x plus 2 goes on the outside. You could use synthetic division on this one if you wanted to. Just make sure you give the equation with all the letters put back in. Oops, that's a minus. It's minus 5x minus 3. So again, with this, you want the first to match the first two. So you would multiply by a 2. And then you actually do the multiplying. 2x plus, okay, I lost track of myself. This is 2x squared, sorry. So then you would get 2x squared plus 4x. You do have to change the signs on the bottom, and then you always add. So then this is a negative 9x, and then make them match again. So you would multiply by negative 9. Now remember, we don't care about the remainder. We care only about the line part, so this part we don't care about. So the equation of the slant asymptote is y equals 2x minus 9. Now, as you know, there's lots of ways to write the equation for a rational function. This one we have a vertical asymptote of x equals 3. X minus 3 will go on the bottom. A horizontal asymptote of y equals 1. The easiest way to do that is to just put that out there, like up 1. If you think of it as just up 1. A vertical stretch of 3, numerator, and reflected around the x-axis. That is the easiest and fastest way to do that problem. It is not the only way. This last page really matches the pattern of the questioning on the last page of the test. Removable discontinuity. This is your whole, I think removable discontinuity is a better name. Helps you remember to remove it. So we're going to factor. These have a 2 in common. The denominator has a 3 in common. I'm going to factor this again. I'm trying to keep all this on the screen here. So this is going to factor into 2 times, that helps if you divide, I guess. That's a 3. X plus 3 times x plus 1. And the denominator is 3 times x plus 3 times x minus 1. So there's our removable discontinuity, which you need to get rid of it. It does have a hole at x equals negative 3. Vertical asymptote, denominator equals 0, bottom equals 0. So we get x equals 1. I'm going to put that on the graph. Horizontal asymptote, this is your, you're looking for the degree or the lead coefficient. Now think about what this would look like if we were to multiply this back out again. You would get 2x plus 2 on top of 3x minus 3. So this is y equals 2/3. It's lead coefficient over lead coefficient. That, of course, is a little bit difficult to graph, but close is good enough. X-intercept. This is the top equals 0. Of course, 2 does not equal 0, so we toss that out. We have an x-intercept at negative 1. The y-intercept, if you go through and make all of the x's zeros, we end up with negative 2/3. Oh, I just put my x-intercept on my y. You probably caught that, but I, of course, didn't. And that's not going to go away. There we go. All right. Sorry about that. So we have x equals negative 1, y equals negative 2/3. You can use your calculator to help you draw the graph. I have a hole. I haven't graphed it yet. If you go to the table, you'll see that the hole is at the point negative 3 1/2. Or just do it yourself and go over to here where x equals negative 3. Of course, mine isn't really that, not drawn very well. But there it is. There's the hole. Behaviors around the vertical asymptote. There is only one. Your vertical asymptote is at negative 1. So as it approaches negative 1 from the left, negative 1 from the right. As it approaches negative 1 from the left, it's to negative infinity. And from the right, it's positive infinity. All of those questions are on there. Number 17, also going to be on there. So it looks like we got a lot of stuff going on here. We have a vertical asymptote at x equals negative 1. Horizontal asymptote at y equals 2. And we have a hole at x equals negative 2. So I'm going to take care of this hole first. It says to write it in factored form. That's a little bit different than the other one. The other one didn't say factored form. This one has to be factors. No little stick out numbers. So you got to be a little bit more picky about this. So I'm going to take care of my common factor first. my vertical asymptote. And so if you can picture these two not being here, they are there, and they should be there in the answer. You want to make sure that you end up with a 2x so that it would have the matching degree on the bottom so that we can get that y equals 2 by having the 2 over 1. Now what you have here, plus or minus, is up to you, and what you put here is also up to you. So this could be 2x plus 5, this could be 2x minus 7, this could be 2x minus 3, whatever you'd like it to be, but it doesn't matter. It's got to have that 2x in there. Let me know if you need any additional help. I'll be available during E&I before the test.